afternoon and most welcome to 1010 of the Heidegger series. I will try to do a little recapture of what we went through in 2009 and 2008 and also add some insights. The first thing I want to mention is this. I've gone through a couple of times. So this is Stephen Wolfram speaking about it is best to start with empty space and not start with existences. After pondering about this for a while, I realized this needs some deepening. We usually think of empty space as nothing, and saying that doesn't mean much. We need to get into the specifics. We have had different empty spaces. What, you say? Well, Euclidean and non-Euclidean space are both empty, but they're both very different. Newtonian space, even if you have the same objects or the same trajectories and the same story, so to speak, mass, energy, put that in Einsteinian space and you get other results, other trajectories. The empty space is not too correct to say it's empty, it's not correct to say it's not empty. It has characteristics, that is correct. It has properties. And I would say by taking the factor of what type of empty space are we talking about, we get a clearer understanding on what it's about. And before I get into Carrie Welch here, I will see if I can mention a little bit about that. Just give me a second here. I have this article by Marek, that's a complicated name, CRNJAC, Crnjac, Institution of Mathematics, Physics and Mathematics in Slovenia, of course. Where else? This article attempts to give a short historical overview of the discovery of fractal Cantorian spacetime starting from the 17th century up to the present. In the last 25 years, a great number of scientists has worked on fractal spacetime, notably Garnier Ord, Garnet Ord in Canada, Laurent Notal in France, and Mohammed Al-Nashi in England. And what it's about is taking in what sort of space do we put the things into, and what are the things doing at the same time, not missing out on anything. I learned about this thing of reality, so to speak, the back way. I noticed there were considerable differences, and those differences puzzled me, and then I realized they were because of we were assuming different spaces. Curved space does not give the same effect as flat space. In flat space, a point, 2 points will have the shortest trajectory as a straight line in between them. This is how we normally think about those things. But that's not the case in non-Euclidean space. There, that shortest line is curved actually. Whereas in flat space it would be longer if it was curved. It would be dome-shaped or valley-shaped, convex or concave depending on your perspective. But this could also be a general hint. We are keen, or we are prone, that's the word, we are biased towards disregarding one of the two things. In Newtonian physics, is usually we disregard the coordinate system and we just go into the facts. But different coordinate systems give different results. And to understand the whole thing, you need the coordinate system and the result. And this is in contrast to absoluteness. And oddly enough, although the word absoluteness gave the indication of something absolute, always valid, this is not the case. It has to be changed to absolute, means absolute in a certain coordinate system or a system of space. The topology of space is very important as well. The terrain where you build the house is important for the structure of the house. You can give example where it's completely obvious, but you can also give example where it's not obvious. Imagine that you are a prospector, you hire some entrepreneurs, some builders, and you have this enormous flatland to place your buildings in, for instance Holland. If you've been doing that for a long time, you start to disregard a possible curvature being important. And the same goes for ordinary people. And the reason why we disregard is not so much that we should disregard, is that we get a claim to disregard those rather important factors. Because we all talk the same way and we don't do any actual calculation. But were you, as the builders Tommy Byggare here in western Sweden, specializing in souterrain buildings, it will not be possible for you, at least not in the workplace, to forget the curvature of reality. But as we normal people, everyday people, the layman, the people that the book is pointed towards, normally don't do souterrain building. They assume, unbeknownst, a flat space. And that is when the problem starts. And I would say, I would specify that even a bit more, or hint to specification. I would say it's not so much it's a flat space, it is that you completely forget about space having properties. And there begins the problem of absoluteness. And once absoluteness has sort of tied a knot on knowledge itself, and I would compare that to this gastroscopic operation you could do if you eat too much. I sometimes do that, as obvious. And if you do that, they can tie a knot on your stomach to make it smaller, and then you won't eat as much. This knot on knowledge, which I call absoluteness, which is not what it says it is, it's a disregard for one factor caring more about another factor, until in the end you don't know that there are two factors, and then you get this sense of absoluteness. But I would say absoluteness is always taking as many parts in as possible, but you at least needs to have what sort of coordinate system and where are the coordinates sitting. That you need. I think it's rather obvious, otherwise whatever you try to construct or think of won't be complete. Whereas it's so much easier for our laymen who don't do construction to assume absoluteness as a thing. It becomes a habit, but as a habit it is disastrous for thinking and knowledge, I'd say. This is building up unnecessary limitations, and as always those limitations are in place before the fact. I mentioned before, seeing the world in sounds, vision, tactile sense, proprioception and so forth doesn't even make sense. Why would nature build human beings as having separate senses? I think more common and an explanation I could buy into is rather that at least eyes are very visible, you move them around, and your ears sticking out and other things. Then you for some reason assume that to having existences by themselves, and then you sort of transpond them to reality, and you do that before the fact. But from an evolutionary perspective it doesn't make sense. So evolution is actually in this case one very effective deconstructor of the idea of a centrism, and the centrism would in this case be senses first and then reality. That is the centrism. Reality is somehow separable or separatable from the senses. Senses are one thing here, they are different, there are 5, there are 6, 7 depending how you count, and the reality is out there. Well, look at it evolutionary. The first single cell creatures, they didn't even differentiate between action, perception and eating. It was the same thing. And I would say exhausting waste is in the same mode there. You do that as one thing. There wouldn't be a purpose in evolution either why we should have 5 senses separable. It would be much more effective to have everything at once. If you were hunted by a large animal, a dinosaur or whatever, you don't look around and see, what do I see, what do I hear, what do I feel, what do I taste, what is my proprioception, what is my balance, what is my acceleration. You simply don't do that. It doesn't make sense. Use your thinking process to discover this to be absolutely wrong. Do sharpen your thinking until it's that sharp that you can go in and make a cut. Make a cut somewhere, cut off the dead meat. The dead meat being the idea of absoluteness. Not something definable, something you have to understand. So Nayats moves into a historical overview leading to fractal spacetime. What sort of spaces did we have before? And the very first seed of something that could look like fractal spacetime. He begins following. Historical overview of ideas leading to fractal spacetime. The idea of hierarchy and fractal-like self-similarity in science started presumably first in cosmology before moving to the realm of quantum and particle physics. It is possible that the English clergyman T. Wright was the first to entertain such ideas. Later on, the idea reappeared in the work of the Swedish scientist Emanuel Swedenborg, and then much later in a more mathematical fashion in the work of another Swedish astrophysicist, C. Challier. In 1983, the English-Canadian physicist Garnier Ord wrote a seminal paper and coined the phrase fractal spacetime. Ord set out to take the mystery out of the analytical continuation. We should recall that an analytical continuation is what converts an ordinary diffusion equation into a Schrödinger equation and a telegraph equation into a Dirac equation. Analytical continuation is thus a shortcut quantization. However, what really happened is inexplicable. Ord showed, using his own invented quantum calculus, that analytical continuation, which consists of replacing ordinary time t by imaginary time, it were I the square root of -1, is not needed if we work in a fractal-like setting, i.e. fractal spacetime. Although rather belated, Ord's work has in the meantime gained a wider acceptance and was published, for instance, in Physics Review. Therefore, one is hopeful that this message has found wider understanding. It is the transfinite geometry and not quantization which produces equations of quantum mechanics. Quantization is just a very convenient way to reach the same results fast, but understanding suffers in this process of formal analytical continuation. Similar work, but not identical, was carried out by the French cosmologist Laurent Notal 15 years ago. Notal wrote a book entitled Fractal Spacetime, that was in 93, and Microphysics, published by World Scientific in 93. Notal connected scaling and Einstein's relativity to what is now called scale relativity theory. Then came the next quantum jump around 1990, when M.S. El-Nashi, who was originally working on elastic and fluid turbulence, began to work on his Cantorian version of fractal spacetime. He showed that the n-dimensional triadic Kentoscent has the same Hausdorff dimension as the dimension of a random inverse golden mean, Sierpinski space to the power n minus 15. And we talked earlier about Sierpinski space. I think it suffices to mention here that Sierpinski space is part of a wider range of what you could call fractal geometry. But since it doesn't have an underlying absolute foundation, there is not such a thing as fractal geometry. Well, let's call it real geometry. But it's similar to the Mandelbrot set, vaguely. In the year 1995, the Nobel laureate Professor Ilya Prigogine, Otto Rössler, and M.S. El-Nashi edited an important book entitled Quantum Mechanics, Diffusion, and Chaotic Fractals. In which the basic principle of fractal spacetime was spelled out. Sometime later, El-Nashi, using the work of Prigogine on irreversibility, showed that the error over time may be explained in fractal spacetime. A few years later, two of El-Nashi's papers on the subject were noted by Thomson Essential Science Indicators as the most cited new frontier paper in physics and as a hot paper in engineering. Second paragraph here of Cerniak's paper. Concept of E-infinity theory. In the following years, a basic conceptual framework of new space-time theory with application to high-energy particle physics started to emerge. The main idea of El-Nashi's E-infinity theory is in fact a sweeping generalization of Einstein's general theory of relativity, namely introducing a new geometry for space-time which differs from the space-time of our sense of experience. Physical space-time is taken for granted to be smooth and flat, Euclidean geometry. General relativity persuades us that the Euclidean 3 plus 1 dimensional space-time is only, and listen now, an approximation, and that the true geometry of the universe in the large is the reality of a four-dimensional curved manifold. In E-infinity theory, we take a similar step and argue that space-time at quantum scales is far from being the smooth, flat and passive space which we use in classical physics. In particular, the geometry of chaotic dynamics, namely fractal geometry, is reduced to its quintessence, i.e. Cantor sets, and is employed directly in the geometrical description of the vacuum fluctuation of space-time. Vacuum fluctuation and mass spectrum of high-energy particle physics. As well known, special relativity fused time and space together. This is called space-time, rumtiden. Then came general relativity and introduced a curvature to space-time. Kaluza and later on Klein added one more dimension to the classical four in order to unify general relativity and electromagnetism. That Klein is the one with the Klein bottle as well. This extra fifth dimension was supposed to be rolled up in a tiny pipe with a radius of the order of magnitude of t up till minus 33. The dimensionality of space-time played a paramount role in the theoretical physics of unification and led to the introduction of the 26 dimensions of string theory, the 10 dimensions of superstring theory, and finally the heterotic string theory with the dimensional hierarchy 4, 6, 10, 16 and 25. In E-infinity theory, El-Nashi admit formally infinite dimensional real space-time. This infinity is hierarchical in strict mathematical way, and he was able to show that E-infinity has a finite number of dimensions when observed from a distance. A low resolution of or equivalent at low energy, the E-infinity Cantorian space-time appear as a four-dimensional space-time manifold. The four-dimensionality is a probabilistic statement, a so-called expectation value. The Hausdorff dimensions of this topologically four-dimension like pre-manifold is also a finite value equal to 4 plus phi up in 3 equals 4.23 and so forth. There's too much mathematics here. I'm going to make a jump to if we project space-time of vacuum fluctuations on a Poincaré, the coffee drinker, circle, we will see a hyperbolic tessellation of the circle with predominantly Klein curve-like geometry. This is an important part of El-Nashi's thesis that actual quantum space-time strongly resembles the hyperbolic geometry of the ramified gamma Klein modular curve. The limit set are well-known Möbius-Klein transformation, Möbius strip and Klein bottle transformation of this space, which may be represented using the Beltrami-Poincaré methods of hyperbolic geometry, is an elementary random Cantor set. Quantum spacetime is conceived here as a hyperbolic fractal in which the low resolution 336 triangles major parts in the original Klein curve, whilst the high resolution part at the circular boundary may be considered as transfinite correction using infinitely many increasingly smaller triangles. The procedure is called compactification. The total equivalent number is normally equal 336 plus 3, 339. The derivation is 137 and is explained in figure 11. Well, let's have a look at this triangle. This is how we build up space in this model. And just let me put in a teaser here. Everything we have to do is dependent on topology. Not only statistics, physics, but there is also a space implemented in understanding philosophy, ideology, literature. It's a space of opposites, it's a space of sequence, it's a space of length, connection, connectivity. So there is always a space present, and I think one of the main problems is, as actually Stephen M. Rosen pointed out, is that we think space is something, for some mad reason, only physical. And here I can't blame the old Greek, because they did not think in that way. It was just maybe the most extreme of the philosophers who didn't even realize space was a thing. They saw space as an absolute with no characteristics, or the characteristics being constantly the same and therefore negligible. They are not negligible, they are incredibly important, and ignoring them will have disastrous effects. As I said before, in the layman, it will create a perception of an otherworldly creature, a panopticon, who sees the absolute space. But to be honest, absolute space is there is something called the user illusion, and absolute space I would call the non-user illusion. It's not a proper illusion because you can't perceive it, and as soon as you start to think about it, look into it, it disappears. And that is not the characteristics or properties of real illusions, because real illusions using other methods to be dissolved, epistemology or physics, something like that. This is a thinking thing, so it's more correct to call it a thinking deficit in certain areas. Have a look, see here. This is one of those very interesting figures. I hope it's visible. That's the vague attractor. So there is a strange attractor, but there is also a vague attractor. And once you go further into topology, you will realize that strange attractor or vague attractor, they are all effects of space itself. They are not physical in the sense. They do take physical character, but they are not constructed from physicality. Physicality is a later thing, so to speak. And I think that's something I really like, and that is that absolutely common sense and normal assumptions about reality in the big can bring you completely wrong. That's absolutely interesting for me. This is one of the things I like. When there is no delusion going on, no illusion, no intervention, no deceitfulness, you are just using your good handy granny intuition and you use them on reality as a whole, and then everything goes haywire. And I hope you understand by now that there was no possibility before quantum mechanics or the theorem of Gödel, Schrödinger's equation, to understand these things. None whatsoever. We were using the common sense we had, and that had been legit for ages. And this is also, I need to point out, without knowledge we are lost, and knowledge does have a real sense to it, not academic knowledge, like making up words or concepts, constructing them like you have a printing press and you print your own paper money, and oh, I get richer and richer and richer, I get more and more concepts, and I put the concepts into a certain order, as this fallacy of a human being, Noam Chomsky, did. He's just producing things. And what it makes it so despicable is he is actually genius when it comes to other areas. This is a man who spent his geniality in destroying human knowledge. But not by malintent. Lack of knowledge is the problem. And knowledge is real. Comes with a book, comes with a experimentation. And that cannot be reduced to something that we can sort of think up before 1927. It cannot happen before 1927. Very important to remember. And that's a good, I think that's the best hint I can give at this stage, at lecture 10,010. Try to figure this out. It cannot be understood before 10,010, because knowledge is real. It's not something you can imagine, not even on a tropical beach with a coconut with a straw in it, having a delicious drink, and all the pleasures in the world is around you. You can absolutely relax, and then you sort of invent quantum theory. Knowledge is real. It has a timing. It is discovered, and it's not necessary. That discovery is not necessary. And maybe you understand my quarrel with those people who says history is necessary, like Hegel and other people. That development happened by itself and you don't have to do anything. I would say that is sheer nonsense, and combined with the idea of passive perception that we have and passive thinking as we have, which is the antithesis of being human. And I'm not making an ideological course here. I would say it was inevitable. There's nothing. Since knowledge is constructed us, there is nothing we can do. But we were lucky, and experimentation showed us another way things could be. Well, I think it's better to round up here. I say thank you very much, and I wish you a very pleasant afternoon. And I think it would be best to sort of wind up with having a look around here. Nice nature. It's the 1st of June, and all the students are coming out with their hats, and here we have some oddity. It takes some explanation. I don't know what this is for, but I seem to be seeing them everywhere these days. They're rather heavy. They seem to contain something, and what is it? Ah, it's a gas bottle. What it's doing here, I don't know. Ah, it's in Sweden. It's kväveoxidul. Seem to contain something. It all makes sense now. Okay, I say thank you very much and have a pleasant afternoon.